For nearly our entire history, we, Homo sapiens, have shared this planet with other kinds of humans. Imagine a world where you might encounter a different type of person, with a different body, a different culture, and a different kind of intelligence. That world was our Earth, just tens of thousands of years ago. So, what happened to these other human species? Who were they, and how did our own ancestors survive when others did not? Today, we're journeying back in time to meet 7 major prehistoric human species, from the pioneers who first walked out of Africa to the famous Neanderthals. Get ready to meet your ancient cousins. 1. Homo habilis. Our story begins not with a roar, but with the deliberate, calculated crack of stone against stone. Over 2 million years ago, in the sun-scorched landscapes of East Africa, a new chapter in the human saga was being written. This chapter's author was not a hero king or a mythical figure, but a humble, clever ancestor known to science as Homo habilis, the handy man. To understand them is to witness the very dawn of technology, a pivotal moment where instinct began to be guided by intention. Before Homo habilis, the world was dominated by the Australopithecines, like the famous Lucy. These ancestors were bipedal, a crucial adaptation. But their lives were still largely dictated by the same rules as other primates. They might have used found objects, a stick to dig for termites, a sharp rock to scrape with, but there was no evidence of a conscious design, of creating something new for a specific purpose. The world was a pantry. You took what you found. Homo habilis changed that. They looked at the raw materials around them and saw not just rocks, but potential. They became the first chefs in the kitchen of invention. The name handyman was bestowed upon them by the legendary paleoanthropologists Louis and Mary Leakey, who discovered the first fossils in the early 1960s in Tanzania's Olduvai Gorge. The name is perfectly literal. It doesn't mean they were marginally useful around the house. It means they were the first makers of stone tools. Their hands, more dexterous and human-like than those of their ancestors, were capable of the precise grip needed to strike one rock against another at just the right angle with just the right amount of force. This was not random bashing. This was the birth of industry, the Olduvai tool tradition. So, what did a Homo habilis look like? If you were to encounter one, you would likely see a creature that still retained many ape-like qualities. They were small, standing only about 3.5 to 5 feet tall, and their arms were long and still suggested a life that included time in the trees. Their face was more primitive than ours, with a protruding jaw and no chin, but the most telling feature was their head. Their brain was a revolution, while still only about half the size of a modern human brain, averaging around 610 cubic centimeters. Compared to our 1350, it was significantly larger than that of any Australopithecine. This expansion in brain size is the key that unlocked everything else. It represents a new kind of intelligence, one capable of foresight, problem-solving, and complex social learning. Now, let's examine their masterpiece, the Olduvai toolkit. To our modern eyes, these tools look like simple, broken rocks, but to an archaeologist, they are sophisticated instruments. The core of the technology was the flake. A Homo habilis craftsman would select a hard hammerstone and a finer-grained core rock, like basalt or flint. With a series of carefully aimed blows, they would knock off several sharp razor-edged flakes. The leftover core, now shaped with a jagged edge, became a chopper, perfect for smashing open bone marrow or hacking apart tough animal hide. But the real genius was the flakes themselves. Light, sharp, and versatile, they were the Swiss Army knives of the Paleolithic. They could be used for slicing meat off a carcass, cutting tough vegetation, whittling wood into a point, or scraping hides clean. This was a modular system, a toolkit of multiple components for multiple jobs. This technological leap fundamentally changed their diet and their place in the ecosystem. Before tools, our ancestors were likely scavengers, waiting for a lion to finish its kill, and then darting in to grab whatever scraps were left. A dangerous and unreliable way to live. With sharp stone tools, Homo habilis could become a more effective scavenger and possibly even a hunter of small game. They could efficiently slice meat from a bone, something impossible with teeth and nails alone. Most importantly, they could crack open long bones to access the rich, fatty marrow inside. Marrow is a calorie-dense, nutritious superfood, crucial for fueling that large, energy-hungry brain. This created a powerful feedback loop. Smarter individuals made better tools, which provided better food, which allowed for the development of even larger brains. This is the cognitive revolution in action. Their social world would have been more complex than that of their predecessors. Making tools isn't just a solo act. It requires observation and learning. It's easy to imagine a group gathered around an experienced toolmaker, watching the technique, learning which rocks make the best cores, which strikes produce the best flakes. This is the foundation of culture, the transmission of knowledge from one generation to the next, not through genes, but through taught behavior. A shared kill site, littered with stone flakes and broken bones, suggests cooperation. They may have worked together to drive off other scavengers or to defend their precious finds. The world of Homo habilis was a dangerous one. They were not the apex predators. They shared their landscape with saber-toothed cats, giant hyenas, and other formidable creatures. Their tools were likely used for defense as much as for butchery. A sharp stone flake in the hand is a formidable weapon against a competitor. Their ability to process food more efficiently may have also allowed for larger social groups, and there is safety in numbers. Finding safety in a tree or a rocky outcrop at night was likely a key to survival. The legacy of Homo habilis is immense. They were the pioneers of the technological path that defines our genus, Homo. They proved that intelligence and adaptability could be a more powerful survival tool than brute strength or sharp teeth. While the exact evolutionary path is still debated, it is widely believed that Homo habilis was a direct ancestor, or a very close cousin to the ancestor of Homo erectus, the species that would take these first tools and walk with them out of Africa to conquer the world. The handy man didn't just make the first tools, they laid the foundation for everything that was to come. They turned a rock into a key and unlocked the future of humanity. 2. Homo erectus, the pioneer. If Homo habilis was the inventor of the first toolkit, then Homo erectus was the adventurous cousin who took that technology, packed a bag, and decided to see the entire world. Emerging in Africa around 1.9 million years ago, this species represents a quantum leap in human evolution. They were the first to truly look and behave in a way we would recognize as human. Their name, meaning upright man, is perfectly apt, as they were the first of our ancestors to have a modern, long-limbed body plan built for endurance and exploration. The physical differences from their predecessors are striking. Homo erectus stood tall, with some individuals reaching heights of over 6 feet. Their long legs and short arms were built for striding, not climbing. This was a body designed for life on the ground, for covering vast distances efficiently across the savanna. This shift in anatomy marks a final break from a life spent partly in the trees. They were committed ground dwellers, and their world was about to get much, much bigger. Perhaps the most significant achievement of Homo erectus was becoming the first global citizen. Around 1.8 million years ago, they did something no human species had done before. They walked out of Africa. Their migrations were slow, taking place over hundreds of generations, but they were relentless. Fossil and tool evidence places them in the Caucasus Mountains of Georgia. By 1.7 million years ago, they reached the tropical islands of Java in Indonesia and the far east of China nearly as early. This was a dispersal across unimaginable distances and into wildly diverse climates. What drove this great migration? The reasons were likely a combination of push and pull factors. Climate fluctuations may have changed their African habitats, pushing them to seek new resources. Their increasing intelligence and adaptability gave them the confidence to explore. But most importantly, they were following the food. Their improved hunting skills allowed them to track game herds, and those herds were moving into new continents. They were pioneers following their dinner. A key to their success was a significant upgrade in technology. While they started with the old Darwin tools of Homo habilis, they soon revolutionized them. Homo erectus invented the Herculean hand axe. This was not a simple smashed rock. It was a symmetrical, teardrop-shaped, bifacial tool, making it required incredible foresight and skill. A craftsman had to carefully flake both sides of a stone core, envisioning the final form inside the raw material. This is the world's first truly standardized tool design, a template that persisted for over 1 million years. The hand axe was a multi-purpose marvel. It was a butchery knife, a woodworking tool, a digger, and a projectile. Its symmetry suggests not just function, but perhaps an early sense of aesthetics. Finding these hand axes from South Africa to England to India shows that the knowledge of how to make them was being faithfully passed down through generations. This represents a cultural tradition, a shared technology that connected disparate populations across the ancient world. Another monumental discovery is attributed to Homo erectus, the taming of fire. The earliest strong evidence, from sites like Wonderwork Cave in South Africa, dates back to around 1 million years ago. Fire was a game changer. It provided warmth, allowing them to survive in colder climates far from their African origins. It offered light, extending the day and providing protection from nocturnal predators. But its most profound impact was on diet. Cooking food, especially meat and tough tubers, made it easier to chew and digest. This process unlocked more calories and nutrients, which further fueled the development of their already large brains. Some scientists argue that cooking was a crucial factor in allowing the human brain to grow to its modern size. Fire also became a social tool, creating a natural hearth for groups to gather around, share food, and strengthen social bonds. This was the first living room. Their cognitive abilities were clearly advanced. Their brain size, averaging about 900 cubic centimeters, overlaps with the lower range of modern humans. This intelligence is reflected in their complex tools and their ability to adapt to so many different environments, from grasslands to forests to mountains. There is also evidence that they were skilled hunters, not just scavengers. They likely used coordinated strategies to hunt large game like elephants, antelope, and horses. The social world of Homo erectus was undoubtedly more complex than any before them. Their hunting strategies required communication and planning. The long childhood suggested by their fossilized teeth indicates an extended period of learning, where parents and elders taught the next generation how to make hand axes, control fire, and track animals. This transfer of knowledge is the bedrock of culture. One of the most famous Homo erectus fossils is the Nariokotomboy from Kenya. This nearly complete skeleton of a young male provides a stunningly clear window into their biology. He was already 5 feet 3 tall as a teenager, and would have reached over 6 feet as an adult. His body was slender and athletic, built for a life of constant movement. His anatomy was so modern that had he been dressed in contemporary clothing, he might not have drawn a second glance on a city street today. The longevity of Homo erectus is a testament to their incredible success. As a species, they persisted for over 1.5 million years. To put that in perspective, our own species, Homo sapiens, has only been around for about 300,000 years. They outlasted every other human species by a colossal margin. Their reign is the longest of any human species to date. Their eventual disappearance is still a subject of debate. Some populations likely evolved directly into new species, like the Denisovans in Asia or Homo heidelbergensis in Europe. Others may have simply been outcompeted by newer arrivals, including our own ancestors, but they never truly vanished. Their legacy is in us. Through interbreeding or direct evolution, their genes and their adaptations are a part of our own biological heritage. Homo erectus was the original pioneer. They took the first timid steps out of humanity's cradle and onto the world stage. They mastered new technologies, conquered new lands, and tamed a fundamental force of nature. They were the first to possess the physical and mental toolkit that would eventually allow humans to dominate the planet. In every sense of the word, they were the foundation upon which all later human history was built. 3. Homo heidelbergensis. In the grand narrative of human evolution, there are inventors, there are pioneers, and then there are bridges. Homo heidelbergensis is that crucial bridge, thriving between approximately 700,000 and 200,000 years ago. This species stands at a pivotal crossroads. They are the last common ancestor we share with our enigmatic cousins, the Neanderthals. To understand them is to find the point where our family tree splits into two mighty branches, one leading west to Europe and another south to Africa. Fossils of Homo heidelbergensis have been found across a wide range, from the fossil-rich sites of Ethiopia and South Africa to the river valleys of Germany, Spain, and even England. This wide dispersal immediately marks them as a successful and highly adaptable species. They inherited the world explored by Homo erectus and began to refine it, becoming more specialized, more intelligent, and more formidable. Physically, Heidelbergensis was a robust and powerful human. They had a large body frame, well built to conserve heat in the cooler climates of Pleistocene Europe. Their skull was large, housing a brain that was, on average, just as big as ours, around 1200 cubic centimeters. However, the shape was different, with a broader, lower profile and prominent brow ridges. Their face was less projecting than earlier species, but still retained a heavy, strong look. The most significant aspect of Homo heidelbergensis is their evolutionary position. Populations of these humans living in Europe became increasingly isolated by repeated ice ages. Over hundreds of thousands of years, natural selection shaped them for survival in a cold world, eventually evolving into the classic Neanderthals. Meanwhile, the populations that remained in Africa faced different pressures and continued on a separate evolutionary path that ultimately led to us, Homo sapiens. This dual destiny makes Homo heidelbergensis the common ancestor. They are the stem population from which the two most famous human lineages diverged. Studying them allows us to see the shared traits we have with Neanderthals and to identify the unique changes that would later define our own species. Their tool technology represents a major step forward from the Acheulean hand axes of Homo erectus. While they continued to make these large, iconic tools, heidelbergensis groups began to innovate. They developed the Levallois technique, a sophisticated method of stone knapping. This involved carefully preparing a stone core so that a flake of a predetermined size and shape could be struck off in a single blow. This was a move towards efficiency and standardization. These prepared flakes were then refined into a wider variety of specialized tools. We see the first consistent evidence of hafting tying stone points to wooden shafts to create spears. This was no longer just a handheld knife. This was a composite weapon. This innovation suggests a leap in cognitive ability, requiring abstract thought to create a tool from multiple components for a specific, future purpose. These spears were not for show. Homo heidelbergensis were the first unequivocal big-game hunters. At sites like Squijning in Germany, archaeologists have found incredibly well-preserved wooden throwing spears alongside the butchered remains of numerous horses. These spears are expertly crafted, balanced for throwing, and represent technology that would have been effective even tens of thousands of years later. This was coordinated, strategic hunting on a grand scale. Hunting massive, dangerous prey like elephants, rhinos, and horses required unprecedented levels of planning, communication, and social cooperation. It suggests a complex social structure where individuals worked together for the common good. A successful hunt would have provided a windfall of food, supporting larger, more stable groups. This social complexity is a key inheritance they passed on to both their Neanderthal and human descendants. Further evidence of their advanced social and cognitive world comes from their relationship with the landscape. They often established seasonal camps, returning to the same locations repeatedly. Some sites, like Terra Amata in France, show evidence of temporary huts built with posts and covered with animal skins. This is a move towards creating shelter, not just finding it. It represents a desire to modify the environment for comfort and safety. The most tantalizing evidence for their symbolic thought, a precursor to modern culture, comes from a site in South Africa. At a place called Kabwe, a heidelbergensis skull was found that may show evidence of a ceremonial burial. While debated, it sparks questions about their relationship with the dead. Furthermore, in South Africa, a chunk of red ochre was found with a deliberate, geometric engraving. This abstract design, created by a human mind over 250,000 years ago, is a powerful hint of a capacity for symbolism and art. Their ability to adapt is demonstrated by their range. From the foggy, cool forests of Europe to the open, arid grasslands of Africa, heidelbergensis populations thrived. They were generalists who could hunt the diverse megafauna of each continent and likely foraged for a wide variety of plants, nuts, and other resources. This flexibility was the key to their long-term success across such a vast geographic range. Communication was undoubtedly a critical tool for their survival. While we have no direct evidence of their language capabilities, their complex hunting strategies, tool-making techniques, and social structures would have been impossible without a sophisticated form of communication. Many paleoanthropologists believe that Homo heidelbergensis possessed a proto-language more advanced than simple grunts, but not yet as complex as modern human speech. The world they inhabited was a challenging one, defined by the Pleistocene ice ages. Glaciers advanced and retreated, sea levels fell and rose, and ecosystems changed dramatically. This was not a stable world. The success of Homo heidelbergensis is a testament to their resilience and their cultural buffering, their ability to use tools, social groups, and knowledge to overcome environmental hardships. Their eventual disappearance is not a single event, but a gradual transformation. In Europe, they slowly evolved into Neanderthals, becoming more and more specialized for the cold. In Africa, they continued to evolve, with brains possibly reorganizing and cultures becoming more complex, setting the stage for the emergence of Homo sapiens. They didn't go extinct. They simply changed into something new. The legacy of Homo heidelbergensis is profound. They bequeathed to Neanderthals a robust build and a mastery of the Eurasian landscape. They passed on to us, in Africa, the potential for the symbolic and technological revolution that would follow. In them, we see the deep roots of hunting, complex sociality, and perhaps even the first faint sparks of art. They were the last common ground, the ancestral heart from which humanity's most famous branches sprang forth to make their separate marks on history. #4. Homo neanderthalensis, the famous cousin. When we imagine another human species, one face invariably comes to mind: the heavy brow, the large nose, the robust body. This is Homo neanderthalensis, our most famous and most misunderstood evolutionary cousin. For over 300,000 years, they were the undisputed masters of Europe, thriving through an ice age that would challenge modern humans. They were not primitive brutes. They were intelligent, adaptable, and deeply human in their own right. The classic Neanderthal physique was a masterpiece of evolution, engineered for survival in a cold climate. Their bodies were stocky and powerful, with a broad chest and short limbs, a build that minimizes surface area and conserves heat. Their large, broad noses were likely an adaptation to warm and humidify the dry, frigid air of the Ice Age. They were incredibly strong, with muscle attachments suggesting a life of extreme physical exertion. Perhaps their most defining feature is their skull. They had a large cranial capacity, even larger on average than our own, often exceeding 1,600 cubic centimeters. This brain was housed in a long, low skull with a pronounced occipital bun at the back, and, most famously, a massive, double-arched brow ridge that sheltered their eyes. This distinctive anatomy has long been used to paint them as primitive, but it simply housed a different kind of human intelligence. Neanderthals were the quintessential opportunistic foragers of the Pleistocene. They were supreme ambush hunters, using the landscape to get close to large game like mammoths, woolly rhinos, and bison. Their strategy relied on power and close-quarters confrontation. Evidence suggests they used thrusting spears, not throwing spears, requiring immense bravery and strength to get within meters of their prey. This high-risk, high-reward hunting defined their lifestyle. Their toolkit, known as the Mousterian industry, was sophisticated and efficient. They were masters of the Levallois technique, creating specialized flakes, scrapers, and points from carefully prepared stone cores. Their tools were designed for a specific purpose: processing animal carcasses, scrapers for hides, points for hunting, and handaxes for butchering. This was a technology perfectly adapted to their primary survival strategy, a life built around hunting megafauna. For decades, Neanderthals were depicted as grunting, simplistic cave dwellers. This image is now completely obsolete. A wealth of archaeological discoveries has revealed a complex inner world. We have compelling evidence that Neanderthals ritualistically buried their dead. Sites like La Chapelle-aux-Saints in France show clear intentional graves, with bodies placed in pits, sometimes in a flexed position. This suggests care for the deceased, and perhaps the first inklings of belief in an afterlife. Beyond burial, we find evidence of abstract thought. At several sites across Europe, Neanderthals collected unusual objects like crystals and animal feathers, which may have held symbolic value. They used pigments like red ochre, potentially for body painting or symbolic marking. In a cave in Spain, they created abstract cave art ladder-like shapes and hand stencils dating back over 64,000 years, long before Homo sapiens arrived in the region. Contrary to the lonely brute stereotype, Neanderthals lived in social groups. Evidence from injured skeletons shows that individuals often survived severe wounds, like broken bones and debilitating arthritis. Healing on this scale requires compassion. The group must have cared for the injured, providing food and protection during their recovery. This is a profound sign of empathy and social bonding, a truly human trait. Their spoken communication remains a mystery, but anatomical evidence suggests they were capable of complex speech. Analysis of a Neanderthal hyoid bone which supports the tongue shows it was identical to ours. Genetic evidence confirms they possessed the same version of the FOXP2 gene, crucial for language development in modern humans. While their language was likely different from ours, they almost certainly had a rich vocal communication system. The world of the Neanderthal was harsh and demanding. They lived through rapid and dramatic climate shifts, from warm periods to extreme glacial maxima. Their survival for so long is a testament to their incredible resilience and adaptability. They were not a failed species. They were a supremely successful one, perfectly evolved for their specific ecological niche in Ice Age Eurasia. The question of what happened to them is one of paleoanthropology's greatest puzzles. Around 40,000 years ago, after Homo sapiens began migrating into their territory, Neanderthals disappeared. The exact cause is still debated. It was likely not a single factor but a combination of pressures. Climate change was intensifying, making their preferred hunting grounds unpredictable. The arrival of modern humans introduced competition for the same resources. Homo sapiens, with potentially more complex social networks and advanced projectile technology, may have had a competitive edge. There may also have been direct conflict. However, the outcome was not pure replacement. We now know that the two species met and interbred. The most enduring legacy of the Neanderthal lives on in us. For most people of non-African descent, approximately 1 to 2% of their DNA is Neanderthal in origin. This genetic evidence proves that when our paths crossed, we did more than fight or compete. We connected. These ancient genes are not mere relics. They continue to influence modern traits, affecting everything from our immune response and hair texture to our susceptibility to certain diseases. The story of the Neanderthal is not a simple tale of extinction. It is a story of a successful, intelligent human species that walked a parallel path to our own. They crafted tools, cared for their weak, expressed themselves symbolically, and dominated a challenging world for hundreds of thousands of years. They were not failed versions of us. They were another kind of human, whose story ended, not because they were inferior, but because of a complex interplay of climate, competition, and ultimately, assimilation. They are gone, but they are, quite literally, a part of us. 5. The Denisovans. In the story of human evolution, most species are discovered through their bones. We find a skull, a jaw, a fragment of limb, and slowly piece together their existence. But one of our most fascinating relatives is known almost entirely through the invisible code of genetics. They are the Denisovans, a mysterious human lineage that has been called the genetic ghost. They are a reminder of how much of our past remains unknown, waiting to be discovered not in the dirt, but in our very DNA. The entire known physical evidence for the Denisovans would fit in the palm of your hand. It was discovered not in a sweeping excavation, but in a small remote cave in the Altai Mountains of Siberia, called Denisova Cave. It was a site long known for its Neanderthal remains. In 2008, a team of archaeologists led by Russian scientists found a tiny, unassuming fragment of a finger bone. It was too small to identify by looks alone. They also found a single, large molar tooth. These were sent for genetic analysis, a routine step. The results, published in 2010, sent shockwaves through the scientific community. The DNA from that finger bone was human, but it was unlike anything ever seen. It was not Homo sapiens. It was not a Neanderthal. It was a completely distinct, previously unknown human lineage. They had discovered a new species from a fleck of bone. The name Denisovan was chosen, after their high-altitude home. What do we know about how they looked? Almost nothing. The finger bone belonged to a young girl, but it reveals little about her appearance. The molar tooth, however, is strikingly large and robust, even larger than a typical Neanderthal tooth. It hints at a powerful build and a distinct dental anatomy. Beyond that, their physical form remains a silhouette. They are a face without features. The true portrait of the Denisovans has been painted by their genetics. By sequencing their genome to an incredibly high resolution, scientists have been able to infer astonishing details. We know they shared a common ancestor with Neanderthals, splitting from that branch several 100,000 years ago. They were essentially sister species, closely related but evolving in isolation for a very long time. This isolation was geographic. While Neanderthals spread west across Europe and the Middle East, the Denisovans spread east across Asia. They became the masters of a vast and ancient continent, adapting to its diverse environments for hundreds of thousands of years. Their world was one of steppes, forests, and high mountain valleys, a realm we are only beginning to explore. The mystery of their physical appearance took a stunning leap forward in 2019. Chinese researchers found a massive, robust jawbone in a cave on the Tibetan plateau. It was dated to be at least 160,000 years old. While no DNA could be extracted, protein analysis confirmed it belonged to a Denisovan. This was the first and, so far, only substantial fossil that gives a hint to their form. It shows they were adapted to live on the high, cold plateau long before modern humans arrived. The most incredible Denisovan legacy is not found in a cave, but in the genes of modern people. When Homo sapiens migrated out of Africa and into Asia, we encountered these mysterious people. And just as we did with Neanderthals, we interbred with them. The genetic evidence for this is clear and profound, but its distribution is telling. The highest levels of Denisovan DNA are found not in Siberia, but in modern-day Melanesians, Aboriginal Australians, and populations across the Philippines and other parts of Southeast Asia. Some groups carry up to 5 to 6% Denisovan ancestry. This pattern reveals a fascinating history. It suggests that the main interbreeding event did not happen near Denisova Cave, but far to the south, in tropical Southeast Asia or some. This genetic inheritance was not a neutral event. It provided a crucial survival advantage. Researchers made a breathtaking discovery, a unique gene variant, known as EPase-1, which helps the body use oxygen more efficiently at high altitude. This variant is common in Tibetans and Sherpas, allowing them to thrive in the thin air of the Himalayas. This gene did not come from Homo sapiens, it came directly from the Denisovans. It appears that modern humans acquired this beneficial gene through ancient interbreeding, and then it was naturally selected for, as populations moved onto the Tibetan plateau. This is the most powerful example of how mixing with other human species provided us with tools to conquer new environments. The Denisovans, adapted to the cold of Asia, gave a gift that still endures today. Their genetic gift extends further. Other Denisovan genes found in modern Pacific populations are involved in immune system function, likely helping our ancestors fight off new pathogens they encountered in Asia. Others affect fat metabolism and skin physiology. Their ghostly DNA is still actively shaping human biology. The puzzle of their culture is the hardest to solve. Without abundant tools clearly tied to their fossils, we can only guess. They lived in Denisova Cave for millennia, alongside Neanderthals at different times. A beautiful bracelet made of polished green chlorite was found in the same layer as the Denisovan fingerbone. It is a sophisticated object, drilled with precision and polished to a shine. But whether it was made by them, or by Neanderthals, or traded, remains an open and heated question. Their story is one of a staggering adaptation to Asia. From the frozen north of Siberia to the high altitudes of Tibet and the tropical islands of the south, the Denisovan genetic signal suggests a species with remarkable versatility. They were the dominant human force across the continent for hundreds of thousands of years. Their disappearance, like the Neanderthals, coincides with the expansion of Homo sapiens. As our ancestors moved through their territory, the same factors likely applied: competition for resources, climate change, and assimilation through interbreeding. They were absorbed into the advancing human wave, their distinct lineage fading into history. But to say they went extinct is not entirely accurate. They are gone as a separate people, but they survive within us. Every time a Tibetan person breathes easily atop the world, the Denisovan legacy is there. They are a testament to the fact that human history is not a simple linear tree, but a tangled web of branches that met, intertwined, and merged. The Denisovans remind us that we carry the ghosts of lost worlds within our own cells, and that the story of humanity is far richer and more complex than we ever imagined. 6. Homo floresiensis, the Hobbit. Discovered on the Indonesian island of Flores, this species is a fascinating enigma. They stood about 3 feet tall and had small brains, yet they crafted stone tools and hunted dwarf elephants. They lived until surprisingly recently, perhaps as recently as 50,000 years ago, meaning they likely shared the planet with us for a time. In the pantheon of human relatives, most stories are of expansion, of growing brains and towering stature. But one species on the island of Flores, Indonesia, tells a completely different story, a story of radical shrinkage. This is Homo floresiensis, a species so bizarre and unexpected that its discovery forced a complete rethinking of human evolution. Affectionately nicknamed the Hobbit, this small being represents one of the most fascinating and puzzling chapters in our family's history. The discovery began in 2003 in Liang Bua, a large limestone cave on the island. An Indonesian-Australian research team, led by Mike Morwood, was digging deep into the cave floor. What they unearthed in September of that year was nothing short of miraculous, the nearly complete skeleton of a tiny, adult human-like individual. The skeleton included the skull, a pelvis, leg bones, and parts of the arms and feet. It was an astonishingly complete find. The individual, quickly labeled LB1, was shockingly small. She stood just about 3 feet 6 inches tall. Her brain was incredibly small, about 380 cubic centimeters, which is closer to the brain size of a chimpanzee or an ancient Australopithecine like Lucy than to any known human. Yet, the sediments surrounding her were dated to a remarkably recent time, just 18,000 years ago. This meant that while modern humans were painting masterpieces in Lascaux Cave in France, a completely different, tiny-brained human was living on a remote Indonesian island. The announcement of Homo floresiensis was met with immediate and intense skepticism. Many leading paleoanthropologists believed it was impossible. They argued that LB1 must be a modern human with a pathological condition, perhaps a form of microcephaly or Down syndrome, that caused its miniature size and unusual features. This launched a fierce scientific debate that would rage for over a decade. Researchers meticulously studied the bones, arguing against pathology. The wrist bones were primitive and shaped like those of an African ape or Homo habilis, not a modern human. The feet were long and flat, without a distinct arch. The skull had a prominent brow ridge and a receding chin. Crucially, many more individuals were found in the cave, all showing the same suite of unique features. This population-level evidence strongly suggested this was a distinct species, not a diseased modern human. So, how did such a strange human come to be? The leading theory is a phenomenon called insular dwarfism. This is a well-known evolutionary process where large mammal species, isolated on islands with limited resources and no major predators, evolved to become smaller over many generations. Smaller bodies require less food, which is a major advantage in a confined ecosystem. The famous dwarf elephants of Crete and Sicily are a classic example. It is believed that the ancestors of Homo floresiensis arrived on Flores somehow, perhaps by rafting on natural vegetation during a tsunami. These ancestors were likely a group of small-bodied, early Homo, such as Homo erectus. Once isolated, the same evolutionary rules of insular dwarfism applied to them. They shrank, generation after generation, until they became the hobbits. Their small brain size, however, is the biggest puzzle. How could a creature with a brain the size of a grapefruit perform complex tasks? The evidence from the cave provides a clear answer. They were far more intelligent than their brain size would suggest. The Liang Bua cave floor was littered with stone tools. These tools were sophisticated, including finely made points, blades, and barbs. They were used for hunting and butchering. Their prey was just as extraordinary as they were. Flores had its own unique ecosystem, a kind of lost world. The hobbits were hunting giant rats, Komodo dragons, and even dwarfed Stegodorna, now extinct relative of the elephant, that had itself undergone insular dwarfism. This was a dramatic reversal of the normal predator-prey relationship, a testament to the hobbits' ingenuity and cooperative hunting skills. The presence of charred bones and fireplaces in the cave suggests they had mastered the use of fire. They could cook their food, provide warmth, and possibly use it to ward off the island's formidable predators. This control of fire, combined with their advanced tool-making, indicates that their cognitive abilities were highly sophisticated, despite their tiny cranial capacity. It forces us to reconsider the direct relationship between brain size and intelligence. The question of their relationship to modern humans is a haunting one. The latest evidence suggests Homo floresiensis likely became extinct around 50,000 years ago. This date is critically important because it coincides with the arrival of Homo sapiens in the region. Did our ancestors directly or indirectly cause their demise? Did we compete with them for resources? Did we bring new diseases? Or was it a volcanic eruption that sealed their fate? The answer remains one of the great mysteries. The existence of the hobbits proves that the human family tree was far bushier and more experimental than we ever thought. It shows that evolution could take a surprising path, creating a small, intelligent, tool-using human perfectly adapted to its own unique island world. They were a remarkable evolutionary experiment in miniaturization. The legacy of Homo floresiensis is profound. They teach us humility. They show that our path to modernity was not the only one. Another kind of human, walking a completely different evolutionary road, survived into a very recent period. Their story expands the definition of what it means to be human. They were not a failed version of us. They were a brilliant success on their own terms, a testament to the incredible adaptability and diversity of the genus Homo. The Hobbit of Flores remains a powerful reminder that the world still holds ancient secrets, waiting to be discovered in the earth, ready to rewrite our history. 7. Homo naledi, the puzzle from the cave. Announced in 2015, Homo naledi shook the paleoanthropology world. Found in a deep cave system in South Africa, this species had a mix of primitive features, like a small brain, and more modern human-like hands and feet. Most mysteriously, their bodies appear to have been deliberately placed in the remote cave chamber, suggesting complex funerary behavior we didn't think was possible for a brain their size. In the year 2013, in the depths of a cave system outside Johannesburg, South Africa, 2 amateur cavers made a discovery that would send shockwaves through the world of paleoanthropology. They squeezed through a narrow vertical fissure known as the chute, and found themselves in a chamber never before entered by humans. The floor was littered with bones. This was the Naledi chamber, and the remains belonged to a completely new species of human relative, Homo naledi. This species would become one of the most perplexing and controversial puzzles in our story. The name Naledi means star in the local Sesotho language, a tribute to the rising star cave system where it was found. The discovery was unprecedented, not just for the species itself, but for the sheer volume of material. The initial excavation recovered over 1,500 fossils from at least 15 individuals, making it the single largest collection of a hominin species ever found in Africa. It was a treasure trove that represented every age group, from infants to the elderly. The first thing that struck scientists was the baffling mosaic of features. Homo naledi had a blend of primitive traits seen in ancestors millions of years old, and more modern, human-like characteristics. Their brains were tiny, only about the size of an orange, averaging 450 to 550 cubic centimeters. This is smaller than that of Homo habilis, and closer to the brain size of an Australopithecine. This was a shock for a member of the genus Homo from the neck down. However, Homo naledi was strikingly modern. Their hands were a particular puzzle. The fingers were long, curved, and adept for climbing, a primitive feature. But the wrist and thumb were robust and modern, perfectly capable of the precision grip needed to make and use stone tools. Their shoulders were built for climbing, but their long legs and human-like feet were clearly designed for walking long distances on the ground. They were a walking contradiction. This combination of ancient and modern anatomy defied easy categorization. It was as if a creature from 2 million years ago had been dropped into a much more recent period. This immediately sparked a fierce debate. Where did they fit on the family tree? Were they a very early branch of the Homo genus that survived in isolation, or did they evolve these modern body features independently? The puzzle was profound, but the greatest mystery of Homo naledi was not in their anatomy, but in how their bones got into the deep, dark, and incredibly remote chamber. The Naledi chamber is exceptionally difficult to access. The route involves a steep climb, a narrow crawl, and a final 40-foot vertical drop down the chute. There are no signs that large predators had dragged the bones in. There is no evidence that a catastrophic flood washed them in. The most provocative and controversial theory proposed by the discovery team, led by Professor Lee Berger, is that Homo naledi deliberately placed their dead in the chamber. This behavior, known as funerary catching, is a complex behavior previously thought to be the exclusive domain of large-brained humans like Neanderthals and Homo sapiens. The suggestion that a small-brained hominin was capable of such a profound and symbolic act was met with deep skepticism. Critics argued that there must be another, simpler explanation. Perhaps there was an easier, no-blocked entrance. Maybe they were living in the cave and became trapped. Yet, the geological evidence continues to support the difficulty of access. The bones show no marks of predation or scavenging. The individuals represent a natural demographic, not a single catastrophic event. The case for intentional body disposal remains strong, though not yet universally accepted. The dating of the fossils was the final, stunning piece of the puzzle. When the species was first announced in 2015, scientists had no idea how old it was. The bones could have been 2 million years old, which would have made sense for their primitive brain size, or they could have been much younger. The answer, revealed in 2017, was astonishing. Homo naledi lived between 236,000 and 335,000 years ago. This date changes everything. This means that while our direct ancestors, Homo sapiens, were evolving in other parts of Africa, a small-brained, primitive-looking hominin was living, and perhaps disposing of its dead, in southern Africa. It completely shatters the simplistic idea of a linear progression from primitive to advanced. Multiple, very different kinds of humans were sharing the continent in the not-so-distant past. The recent discoveries within the Rising Star cave system have only deepened the mystery. In a separate chamber, named the Lesedi chamber, more Homo naledi remains were found, including a remarkably complete adult male skeleton named Neo. This confirmed that the presence of these individuals in the caves was not a one-off event, it was a repeated behavior. Most provocatively, in 2023, the research team claimed to have found evidence of engravings on the walls of the Dinaledi chamber and possible use of fire in the cave system. These claims are the subject of intense scientific debate and require rigorous peer review. If confirmed, they would further challenge our understanding of the cognitive capabilities required for such symbolic behaviors. The story of Homo naledi is still being written. Every answer leads to new questions. They force us to confront our deep-seated assumptions that large brain size is the sole prerequisite for complex, human-like behavior. Perhaps intelligence, culture, and an awareness of mortality can manifest in different ways, in different kinds of minds, that we are only just beginning to understand. Homo naledi is the ultimate puzzle from the cave. They are a reminder that Africa, the cradle of humankind, still holds profound secrets. They show that our history is far messier, more complex, and more wonderful than a simple family tree can represent. They challenge our arrogance, our claim to be the sole bearers of human consciousness. In the dark, silent chambers of Rising Star, a small-brained relative whispers a powerful truth. We are not the only ones who have ever wondered about life, death, and what lies beyond. So, there you have it. 7 major human species that once walked the earth. It's a humbling reminder that our story is far more complex and interesting than a simple linear march of progress. Which of these species do you find the most fascinating? Was it the worldwide wanderer, Homo erectus, or the mysterious Denisovans we're still learning about? Let me know in the comments below. If you enjoyed this deep dive into our shared past, make sure you hit that like button and subscribe to the channel for more journeys into history, science, and mystery. Thanks for watching, and I'll see you in the next video.